Hello, this is the luckiest maths teacher in the world. Today we're going to go through firstly what probability actually is and then what sample space is. So let's start with probability. The word here is likelihood. We're looking at how likely something is to occur or to not occur. Now, you will have some common sense understanding of this. If I said what are the chances or how likely is it that the Broncos will win next year's NRL premiership, I mean, you can all tell that's highly likely. If I say, is it likely that Mr. Luck will wear something awesome today? Of course, that's highly likely. So the answer is yes. But what are the chances that, say, it will snow today? Well, that's very unlikely. But sometimes, with these words, it's hard to actually compare probability because what one person considers likely, the other might consider unlikely. So, what's the probability or how likely is it that it will rain tomorrow? Some people might say it's likely, some might say it's not. It's not always clear cut. That's when maths comes in, and I know you all love it. So let's just look at the number line that I've put up here. It's no different to the number lines we've seen a trillion times this year. So the number line here, as you can see, it goes from 0 to 1. Now the desirable property of numbers, in this case, there's so many good things about them, but one thing that's really important about them in real life is that you can order them. It allows for comparison. So, for example, you might say it's really likely that it'll be sunny today. Your friend might say, yeah, it's probably going to be sunny. But it's pretty hard to tell who actually thinks there's more of a chance of it being sunny. It's hard to compare those probabilities. Another comparison we might want to make, so is it more likely that the Broncos will win next year's premiership or that the Cowboys will win next year's premiership again? Now, that is a subjective question. You will have many different people with many different opinions. But what we're aiming to do in probability is we're aiming to give these events, things that can happen, numbers. So the probability that the Broncos will win next year, we can, by the end of this, assign some sort of number to it because we can order numbers. So the Broncos winning the premiership, that's an event. So what we do is we give it a number between 0 and 1 that explains how likely it is. So if the probability of the Broncos winning next year was, say, 0.8, it would be up here on the number line. Let's say the probability of the Cowboys winning was only 0.25. It would be down here. Okay? Now, just by assigning numbers, I can tell which of these is more likely. And that's the property that we're after here, because 0.8 is obviously a lot bigger than 0.25. And that's what we're trying to get out of this. So I'm going to write up a formal definition that I'd like you to take down. So there's the definition, the numerical measurement of how likely an event is to occur. And as I said, we put it into numbers so we can compare. So numbers at this end of the number line are more likely to occur. So the closer the probability is to 1, the more likely it is to occur. So at this far end, we have events that are certain. So an event that is certain could be if you multiply a number by 0, the answer is 0. That's certain, there's no chance that anything else will happen. Numbers down this end of the number line are less likely to happen. There's more of a chance that they won't happen. And at the extreme here, we see things with probability 0 are impossible. So, an event that is completely and utterly impossible is, for example, if you add together two odd numbers, that you get another odd number. Absolutely no way that that can possibly happen. So we can see on our number line here, this event that I've circled. So if I toss a coin, there's an even chance that I get a head. So it's halfway between 0 and 1. So its probability is going to be a half. Now it's not so important if you don't understand yet where I got that number from, because we're actually going to come up with these numbers. I'm going to show you how to find them in the next lesson. But I just wanted to show you how we can compare events. So this event of getting ahead when you toss a coin is halfway along the number line, and it has a probability of a half. Now if we look at this event here that I've circled, rolling a die and getting a 1, it's a 1 in 6 chance. Now because I've assigned numbers to these events, I can tell you which is more likely. We can see clearly just by looking at the number line that this event here, tossing the coin and getting ahead, is more likely to occur than this event here, rolling a die and getting a 1. Now that doesn't, of course, mean that I will always get ahead, because it's not certain. It's only here on the number line. It's not over here. So, just means that, let's say you were having a bet with a friend, and they said, would you like to bet heads or tails, or would you like to bet on the outcome of the die? This one here would be a better bet. It is more likely to occur. If we tossed heaps and heaps and heaps of coins and rolled heaps and heaps and heaps of dies, we would expect that more heads would come up than ones would come up. So that's all we're getting to today, just understanding that we're giving a number to an event that explains how likely that event is to occur. Now the numbers that we give always must be between 0 and 1. So this is a very important point. If I ask you, say, what's the probability that the Broncos win the competition next year, you can't give me a descriptive word like likely or unlikely. You can't even say 50-50 or 80%. If I ask you the probability, it always has to be between 0 and 1. Probabilities are always between 0 and 1. If it has a probability close to 0, it's unlikely to occur. And if it has a probability close to 1, then it is likely to occur. And as I showed you on the number line, if it is an even chance of occurring, same chance of occurring as not occurring, like the head that I showed you, then its probability is halfway between. It's a half. All right, one more thing we have to do is go through what is sample space. So on your screens now, you can see the definition of sample space. Just take it down. So sample space is the list of all possible outcomes of an event. So again, an event is just something that may or may not occur. So let's say, look at the NRL Grand Final again, Broncos and Cowboys. So they're playing a game. The Grand Final outcome is the event. Who wins that game? That's the event, and the possible outcomes are Broncos win or Cowboys win. Let's look at an easier one. So let's say I roll a die. That's an event, something that may or may not happen. So its sample space will just be the list of all things that could happen. So we usually put it in squiggly brackets like these, and we just list what could happen. So obviously if I roll a die, this is just a normal die that you're used to, I could get a 1, 2, 3, 4, 5, or 6. So in these squiggly brackets here, you can see the list of all the things that could happen if I roll a die. I didn't write heads in there, because if I roll a die, no chance I'm going to get a heads. I didn't write anything about NRL in there, much as I'd like to, because that's got nothing to do with it. This is just the things that may occur when I roll a die. You can get a 1, 2, 3, 4, 5, or 6. Now that's all you have to do to list the sample space. Now this is really important, because next lesson when we actually go to finding numbers, making probabilities into numbers, you will need to know how many possible outcomes there are. So I know you probably already knew this, but we can see very clearly from the sample space I just wrote on the screen that there are 6 possible outcomes. Okay, so what would be the sample space if I toss a coin? Why don't you go and try and write this down? Then I'm going to put the answer on this screen in about 5 seconds, so pause it and see if you got the right answer. Okay, so here's the answer. Toss a coin, I just wrote H for heads, T for tails. There's only 2 possible outcomes. Alright, the last possible example I want you to consider is, let's say I'm picking a marble from a bag, and it has 5 red, 5 yellow, and 2 green marbles. I want to know what the sample space is. So the event is that I pick a marble out of this bag with 5 red, 5 yellow, and 2 green marbles. I want to know what its sample space is. So again, try and do this one yourselves, and then pause the video and see if you're right. So here's the answer. Note, just to save us time, because us mathematicians are a little lazy, we don't need to write out red 5 times because there are 5 red ones. We only need to say the possibilities that will occur. So if I pick one marble, I could get a red, a yellow, or a green. So I only need to write R for red, Y for yellow, G for green. That's it. Nothing more to be done. You don't have to list the same event many times. Even though red and yellow are more likely to occur than green, if we're simply asked to write the sample space, we don't need to include that information. Okay, we'll go through that next lesson. Alright, so that's all for this time. So hopefully what you've got out of today is what probability actually is and what sample space is and how to write it. This has been the luckiest maths teacher in the world. Have a great day.